Okay, so this is a question on Neville's iterated method. So we're supposed to find it in degrees 1, 2, and 3. But what I'm going to start doing is I'm going to start off with let's start with degree 1. Let's do the entire thing. Let's do the entire thing from degree up to degree 3, because really for Neville's iterated method is that for you to get to degree 3, you have to go through degree 1, 2, and then so on and so forth. So really there's no way of us avoiding 1 and 2, so we just have to do them. Okay, so the Neville iterated for degree 3 is basically p 0, 1, 2, 3. And so we're going to find that polynomial. Now, how do we evaluate this polynomial, right? How do we evaluate this polynomial? This polynomial is going to be evaluated by saying we're going to have x3 minus x naught. Then this is going to be p 1, 2, 3 of x there, and then we're going to have x minus x naught, and then minus, then we're going to have x minus x3, then that's going to be p 0, 1, 2 at x. Here's the thing now. We don't have p1, 2, 3, and then we don't have p0, 1, and 2. So remember what I told you? We have to find these things, right? We have to go forth and find these things ourselves. So we're then going to say, okay, what is p1, 2, 3 of x? This is what makes Neville's iterated method very long, because you might think you only have one thing to solve, and then you discover that you have like 6 things to solve before you solve that one thing. Yeah, so we have that over there, and then this one again can be evaluated in the following way. We're gonna say this is going to be x3 minus x1. This is going to be p starting at 1, 2 of x there, and then this is going to be x minus x1. Oh, this is going to be 2, 3. Again, then minus x minus x3. Then this is going to be p 1, 2. Right, p1, 2. Again, we don't have this, so meaning anyway, let me write down the other one. Then the other one is p 0, 1, 2 of x, p 0, 1, 2 of x. That there is going to give us x2 minus x naught, so x2 minus x naught over there, and then this is going to be x minus x naught, and then it's going to be p1, 2 of x minus x2. This is going to be p0, 1. So now, again, we're still not done. We don't have this guy over here, right? We don't have this guy over here. We don't have this one over here, and then we don't have this one over here. So I have to solve these 3 so that we can evaluate these 2, so that we can evaluate this one. That's Neville's iterated method for you. There's a lot of backtracking. So let's start off with this one over here. Then we're going to go to this one, and then we're going to evaluate this one. Then we're going to evaluate these 2, and then finally we're going to evaluate this one. Okay. P0, 1. Start simple. P0, 1 of x of 8.4, right? Let me even write down the points. We're using the same points from the previous question on Lagrange. So, and I have them written down over here, so it's fine. So this one over here now is going to be equal to x minus x naught. Then I'm going to have p1 of x, right? p1 of x minus x1, then p0 of x. Have I written down this right? Okay, that's right. It was looking wrong. I don't know. I want to look at these things for a long time. Start looking the same. They're going to be x1 minus x naught. Okay. Then now we're going to evaluate this. What is our x naught? Our x naught is these values over here. So you're just going to have to keep track of them in your head. So am I. I don't make a mistake somewhere. So we're going to have 8.4 because that's the one we're evaluating, minus what is x naught? X naught is 8.1, right? Then this one is going to be 16.94 8.4410 minus, this is going to be 8.4 minus what's x1? X1 is 8.3. Then that over there is going to be 17.56492 over, then this is going to be 8.3 minus 8.1, right? We're going to have that over there. Am I doing the right thing? No, hopefully I am. It's right here. No, I messed up. It's a mistake I made when I was solving. These are supposed to be swapped. So it's going to be 17.56492, and then this other one is going to be 16.94410, and then we can punch this on the calculator. So basically for this guy over here, it's just a matter of doing the initial solve. So it's going to be 0.3 times 17.56492, that gives me that, minus open brackets 0.1, right? 0.1 times 16.94410, then that divided by 0.2, which is going to give me 17.873 or 87533. So if we were solving, remember in the Lagrange question, the question for Lagrange, this was like also the answer for degree 1. So if we were solving just for degree 1, this is where I would end. But sadly, that's not the life we've chosen. We've chosen to go forward. So then going to solve P1, 2 of 8.4 is then going to equal x minus x1, then this is going to be P2 of x there, minus x minus x2, then it's going to be P of 1 there, taking in the x over yeah, okay, then this is then going to be x2 minus x1, and then we're going to calculate that. Then going to calculate that. It's going to be 8.4 minus what's x1? X1 is 8.3. Then this is then going to be, what is my P2? My P2 is 18.505 minus, then it's going to be 8.4 minus what is x2? X2 is 8.6. Then this is 17.56492 over, then this one over here is then going to be our x2 being 8.6 minus 8.3. Then we're going to punch this on our calculator. This is going to be 0.1. Do you know this? And then I find out I'm not recording. It's not either. 0.1 times 18.505, then minus open brackets negative 0.2 times 17.56492, which is that there, that which is then divided by 0.3, which gives me, this is why I got confused, isn't it? That's going to be 17.87833. So we have that over there. So that's, oh, we're not done. Still have something else to do. Oh my goodness. I still have something else to do over here. Okay, we go to the next one. We go to the next one, and the next one, and the next one, and the next one, and the next one. So we're going to go to the next page. What does the next page require us to do? This one, I'm going to have P 2,3. I'm going to fast track over most of this one because we already know what we're about to do. So it's going to be x minus x2, then it's going to be P3, minus x minus x3, that is going to be p2. Then this is going to be x3 minus x2.
What is long bed?
Okay. Then we're going to have that over there. We're going to have 8.4 minus sorry for the noise in the background. Then it's going to be 8.4 minus 8.6, and then that's going to be P3, which is going to be 18.82091 minus, then it's going to be 8.4 minus
I got this from Lombe.
8.7, and it's going to be 18.50,
This was part of the
51.5, and then this is then going to be this one is going to be 8.7
Since you always love
minus
this fit, I'm gonna work out with it.
8.6. We're going to punch this on our calculator again. I'm redoing the calculations differently from how I did them, just in because well, I made the mistake on my end. So it's going to be negative 0.2 times 18.82091. This is negative something minus open brackets negative 0.3 times 18.515, that punch that on the calculator, then this divided by 0.1 is going to give us this will finally give us 17.87 okay. We're done with the first of three steps, right? Next now is going to be the polynomials of p 0, 1, 2, right? p 0, 1, 2. We're going to run that polynomial. So we're going to make that polynomial. Since we already have this calculated, it's going to be a bit straightforward. Well, no, it won't. But this is then going to be again. So for this one, when we're dealing with more than 1 point, just to prevent getting lost, let's start off with the end point, which is going to be x2 minus x0. So this one is going to be p 1, 2, right? And then here we're going to have x minus of x there. I'm going to have x minus x0 minus then x minus x what was in here? This is x2. Then it's going to be p0, p0, 1. Sorry, I'm starting to everything's starting to look the same over here. I'm not sure on your end, but hopefully I'm not the only one who's these are long questions and they get longer from here. So it's going to be 8.4 minus 8.1 there. Then what was p1, 2? P1, 2 was 17.87,833. 17.87,833 minus P01, which was 87,533. Very small difference. Very easy to get confused. It's going to be x minus, what is our x2? X2 is our x2 is 8.6. So it's supposed to be 8.4 here. 8.4 minus 8.6. Then this is going to be 87,533. So I made a mistake there. 87,533. Yes, this is a very small number. So then that there is then going to give us what is our x2? Our x2 is 8.6 minus 8.1. Then we're going to punch this on our calculator. I'm going to punch this one on our calculator. So it's going to be 0.3 times 17.87833 minus, then this is going to be negative 0.2 times 17.87533. Not there, that's going to be that divided by 0.5 which is going to give us, which is going to give me, according to my calculator, 17.87713. Right, it's 17.87713. Okay, we have that. On to the next one. 15 minutes. Okay, nice. It's a short video. Anyway, on to P1, 2, 3. This is the last one before we do the last one. Before we do this one, yeah, this one should have written down everything correctly. This is going to be. Yeah, no, I made a mistake on this one. Yeah, it's going to be equal to, start off with the denominator. Start with the denominator there. It's going to be x3 minus x1, then it's going to be x minus x1, then this is going to be p 2, 3 of x minus x3, then this is going to be p 1, 2 of x there, then this is then going to equal what item is here? What item is supposed to be here? The item supposed to be here is 8.4 minus what is our x1? Our x1 is 8.3. Then what is our p2, 3? p2, 3 was 87, 36, 3. Oh, didn't make a second. Okay. 17.87, 36, 3. I had made a mistake when solving this one over here. I ended up putting both of them as in 833, 833, which led to the answer being very off to the actual answer. So yeah, luckily I got a mistake there. So we're going to have that there. Then minus, so what is our 8.4 minus x3, which is 8.7, right? And then that one, 1,2 is going to be 17.87833, and then that one over there, the line at the bottom there, is then going to be 8.7 minus 8.3. Punch that on our calculator, just to be sure that whatever I'm finding is going to be right. So this is then going to be 0.1 times 17.87 363 minus open bracket negative 0.3 times 17.87833. That's then divided by 0.4, which is then going to be 17.87715. With this now, we can finally go back and solve this one. I know you're tired. I'm also tired. Don't worry. We're going to say add to the library there. Then I'm going to say new page. Okay, so I'm going to go back to this guy over here. This guy now, this is then going to equal 8.4 minus what is our x naught? Our x naught is 8.1 there. Then what is our P123? Our P123 is 7715. 17.8 77155 minus, this is going to be 8.3 minus, or 8.4 minus 8.7. Okay, so this is 17.87713. So 877 13 over, right, over, then this is going to be our x3 there is going to be 8.7 minus 8.1 is then going to be 0.3 times 17.877155. Then we multiply that minus open brackets negative 0.3 times 17.87713, then divided by 0.6, which will then give us 17.877145. And what you notice is that this is the same answer we got in the Lagrange polynomial, which should make sense because we are evaluating about the same points. So let me just go to the Lagrange polynomial. We have that over there. Since we are looking at the exact same points there, so of course that answer we should expect that answer to at least look the same, which is that there, 771425. So yeah, this is how we go about with Neville's iterated method. It's a long question, and you can't avoid this one. You can't avoid it in the exam. Yeah, so it's just a matter of practice and getting faster and faster at it. At least I started one which is rather long, so we went through all these required steps. So any other question we do is just some added stuff. For instance, in a situation where we only have one, what we've been told to evaluate P1, 2, 4, something like this. So it's not always that they're in order. So there is this weird one over there that we're going to look at. It's straightforward as well, but we're going to look at it anyway. But yeah, I think that's enough. I think we've done quite enough. Let's just let the information just sink in. So next set of videos is going to be on divided difference, and then we're going to do some questions, and then finally we can look at the last topic of numerical analysis. Hopefully, since you guys have enough time before the exam, this is good enough. Peace. Happy studying. Good luck.